Hi there, everybody. So today we're going to review the order of operations. Before we get into everything, let's go ahead and just take a look at this problem here. Okay, I'm going to use tiles and make arrays to show what this problem could look like. So here we go. We have 3 tiles, 1, 2, 3, and I'm going to make an array of this 4 by 4 array. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So here we have 1, 2, 3, 4 by 1, 2, 3, 4, and then we added those 3. We have a total now of, let's see, we have 4 by 4, which is 16, plus the 3, which is 19 tiles. If I look at it this way and I want to do 3 plus 4 and make 4 groups of that, I would have 1, 2, 3, plus 1, 2, 3, 4. There's 1 group. 1, 2, 3, plus 1, 2, 3, 4. 1, 2, 3, plus 1, 2, 3, 4. 1, 2, 3, plus 1, 2, 3, 4. So here I have a total of 1, 2, 3, 4, 5, 6, 7, 14, 21, 28 tiles. Well, that just can't be. We can't see the same problem and come up with different solutions. So that's why we follow the order of operations. The order of operations begins with parentheses. Parentheses, any type of grouping symbol, parentheses, brackets, braces, all of that would be considered during the parentheses part of the order of operations. The next step would be to look and evaluate exponents. Now an exponent is this little tiny number in the corner right here next to a bigger number that tells us how many times to multiply the big number by itself. Now we're not really going to deal much with this today, but eventually in the year we will. The next step is to multiply or divide, and I'm drawing an arrow because we do this whichever we see first from left to right. And lastly, we look for addition or subtraction, again, whichever we see first, going from, you got it, left to right. Sometimes you'll see this referred to as PEMDAS. Don't forget to put these arrows so you remember that we multiply and divide at the same time. Sometimes people even call them GEMS, the G standing for grouping symbols, and so on. Both are correct, but I like to use PEMDAS because it reminds me of all the possible things I could be doing. Let's go ahead and evaluate the expression. It's an expression. We don't see any equal signs here, anything that this should balance with. Evaluate is kind of another word for solve or find the answer. So let's solve or find the answer, evaluate, by going through this sort of check off, which is the order of operations. Are there parentheses? No. Are there exponents? No. Is there multiplication or division? Yes, right here. 7 times 5 gives me that 35. Always rewrite your problem. You never know if you need to go back and check your answer and see where you made a mistake. It also makes the thought process a lot easier. Maybe a little bit more work, but a lot easier to follow. And then 35 plus 3, we can do that addition or subtraction, which we get 38. All right, let's go back to our check sheet using the order of operations. Are there parentheses? Ding, ding, ding. Yes, there are. 28 minus 20 inside those parentheses gives us 8. 8 divided by 4 gives us 2. Now in this problem, we see subtraction and we see division, but we did that subtraction first. Well, those parentheses are there to tell us when we go out of order, when we need to do something first in order to solve. Let's go through our check sheet again for the order of operations. Parentheses, no. Exponents, no. Multiplication or division, yes, I see both. I do the one on the left first. I don't happen to remember what 15 times 6 is, so I'm going to rewrite it so I can use my standard algorithm. 6 times 5 gives me 30, also known as 3 tens. 6 times 1 is 6, plus 3 is 9. So let's plug that into our problem, rewriting it. Then I look for multiplication or division again. I see that division there, so I'm going to solve that part. 10 divided by 2 is 5. And we can finish with our subtraction, 90 minus 5, which is 85. Super duper. Where can we use grouping symbols to make this equation true? So here we're going to put in parentheses. I like to go through and try different spots to put the parentheses to see where it would be true. So let's try if we had done 15 minus 7 first. 15 minus 7 gives me 8, and 8 minus 2 is 6. But 6 does not equal 10, so that is not our answer. Okay, let's look at another place to put the parentheses. What if we put them around the 7 and the 2? Well, 15, 7 minus 2 is 5, 15 minus 5 is 10, 10 equals 10. Ding, 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 we found the correct answer. So we would put those grouping symbols around 7 minus 2, around that difference. If I'm going to compare these two, well, first, let's make some visual observations. I see that one doesn't have parentheses and one does. We're still going to follow our order of operations. Let's go ahead and do 3 times 2, which is 6, and 6 plus 5, which is 11. I looked for parentheses, didn't have them. I looked for exponents, didn't have them. I found that multiplication, did that first. Then I finished with the addition. Here I'm going to do what's in parentheses first, so I'm rewriting my problem. 3 times 7, which is 21. I see that I got different answers. Normally addition would come after multiplication, but those grouping symbols, those parentheses, made me do them first. So we go ahead and we will write a comparison. We did not get the same answer or solution because the parentheses had us go and compute out of order. I think that's a good enough explanation for that. Let's continue on to the next page. On this next page, we need to evaluate the following numerical expressions. Remember, evaluate's just a fancy word for find the answer. Can the parentheses in any of these expressions be removed without changing the value of the expression? So not only are we going to find the answer, but we're going to see if I took the parentheses out of these problems, would I get the same answer as this problem that has them removed and taken out already? So let's go ahead and follow our order of operations. 2 times 5, that gives us 10. I know it's a pain, but we rewrite it every time. Then we again look for multiplication. So I have that 10 plus 6 plus 4. 10 plus 6 is 16, plus 4 is 20. Okay, so that is it without any parentheses. That is our answer when we have removed the parentheses. So let's look at the ones with parentheses. Again, we do what's in those parentheses first. But now, hold up. I see 1, 2, 3 operations in this problem. I'm only used to doing one operation. Well, guess what? When we have parentheses, we still follow the order of operations within those parentheses. So I'm going to come here and I say 2 times. I see I have multiplication in there, which is going to come first. 3 times 2, which is 6. Still adding that 4. And continue with those order of operations within the parentheses. 2 times 5 plus 6 was 11, plus 4. 11 plus 4 is 15. So 2 times 15 gives us 30. 2 times 15 gives us 30. That problem, if I took out these parentheses, I don't still get 30. I would get 20. So B is not going to give us the same answer if I take out the parentheses, the grouping symbols. Again, find those parentheses. So we have 2 times 5 plus 3 times 2 plus 4 is 6. Parentheses are all gone. No exponents. Let's look for multiplication. Here we go. 2 times 5 is 10. 10 plus 3 times 6. Again, look for multiplication or division. 3 times 6 is 18. 10 plus 18 gives us 28. If I take out those parentheses, I get 20, so I'm still not going to get that answer of 28. So that one doesn't work for us. 2 times 5 plus 3, is 8. 8 times 2 plus 4. Parentheses are all done, so look for exponents, no exponents. Solve that multiplication or division. 2 times 8 is 16. So now we have 16 times 2 plus 4. 16 times 2 is 32. 32 plus 4 is 36. I don't get the same answer if I take those parentheses out, because if I did, I'd get 20. So D does not work for us. Let's look at E. I solve what's in those parentheses. Took care of that first set of parentheses. Then I solve what's in the second set of parentheses. 10 plus 6 is 16. 16 plus 4 is 20. If I take out those parentheses, I would still get 20. So E works, and we'll talk about why it works in a second. Here we go. Follow my order of operations. Look for those parentheses. 2 times 5 plus 3 is 8. Times 2 plus 4. Solve what's in those parentheses. 2 times 8 times 2 plus 4 was 6. 2 times 8 is 16. 16 times 6 is 96. If I take out those parentheses, I'm definitely not still getting 96. My question to you is why did E work? Why is it that if I take out these parentheses, I still get the same answer? Well, my response would be this. Here I have parentheses around something that I would do first anyways. I would be multiplying 2 times 5 first because the other order of operations, multiplication, becomes before addition. So I would be doing that first no matter what, whether there's parentheses there or not. Let's look at this bottom problem. It's the last one that we'll do for today. Below is a picture that represents 9 plus 2. 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 1, 2. Super duper. Draw a picture that represents 4 times that sum or that quantity. So I'm going to make 4 groups of that same thing. Let's draw it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, plus those 2. There's 1 group. Here's 2 groups. 2, 3, 4, 5, 6, 7, 8, 9, plus those 2. There's 2 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, plus those 2. There's 3 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, plus those 2. There's 4 groups, and that's what my picture would look like. Now, if I had done 9 plus 2, 9 plus 2 gives us a total or a sum of 11. If I have 4 of those groups, I end up with 44. How many times bigger is 44 than 11, or my expression, 4 times the sum of 9 and 2, than 9 plus 2? Explain your reasoning. So, 4 times the sum of 9 and 2, or the quantity of 9 plus 2, is 4 times greater than 9 plus 2, because it did say explain your reasoning, because I have drawn 4 groups of the same value. All right, that's our explanation for today. Remember the order of operations: parentheses, exponents, multiply or divide, left to right, add or subtract, left to right. Parentheses are there for when we have to go out of the order of operations. See you later.